All right, so far we have gone about, explaining or discussing about quite a lot of things. We started off with our basic networks. What is that for? We also discussed about internet connectivity. We also discussed about various kinds of networks. We discussed about HTTP, HTTPS. So last class we discussed about OSI layer, which we discussed about and then said we, yep. Um, just close the door, okay? Close the door. Uh, so we discussed about that. And in the OSI layer, we said there are 7 layers in the system. It starts with the physical layer and through to the application layer. Now, in this class, what we are going to discuss today is about the various components which are used at the different levels or layers of network connectivity. So what I'm going to do is I'm going to quickly go through that. So in the Zoom, I'll get the whiteboard. New share, whiteboard, share. Can you guys see my whiteboard?
Yes, sir.
Yep. Okay. All right. So today we're going to discuss about so pretend this is the computer and this is another computer. These two chaps are talking. Now, as we discussed yesterday, so how does the data travel from, assuming this is the sender of the data and this is the receiver or recipient of the data, right? Okay, pretend a scenario where computer A is the sender and computer B is the receiver, okay? Now, how does a data travel from one network to the other? So we also discussed within a computer, you've got or something called as an operating system. Then you've got a network interface card. Remember that? Okay. Network interface card. A network port will look something like this. Can you guys see it? Can you guys see my camera?
Yes, sir.
So these are the network ports. You see the yellow ones? It's a modem actually. It's a Wi-Fi router. Okay. And it's got network ports attached to it. Likewise, on every computer you have got a network port. So if you look at the, depending on how the computer is, I don't know how to see it, show it on my laptop, but yeah. So my laptop has got a network interface card as well. Which I've got a cable connected, and that's the cable. Can you see the cable?
Yes.
Can you see it?
Yes, we can.
Yeah, okay. So I've got a network cable attached to it. I've got a network port to which it goes in. So that's a network port, yeah. And this guy has a receiver port as well, which again is a network port. Correct? Now, what are the layers through which it travels? So assuming you're sending a data, okay? So a data in network terms can be, okay, assume that as a chunks of data, which is getting transmitted from one device to another device. Each chunk of data is called a, what is it called? I think I explained this yesterday in the last class. Do you remember? So that's it's called a packet. Okay. Now, so assuming the data is hello. Okay, you send a hello message through whatever protocol you want. You can send a post message through a HTTP protocol. You can send a email message through an SMTP protocol. There are multiple protocols available. We are assuming the basic text transfer, and that can be a copying through multiple protocols as well. Anyway, the packet has the data hello. Now, what are the steps through which the entire process travels? Let's just go through it, right? So the objective of today's session is to understand what are the devices which are involved in every layer of OSI model, and that's all what we are going to discuss today. Okay, because I want you to be clear how this entire logistics work. Okay, now someone is sending a data packet called hello. You've got a cable connected, obviously, assuming that it is not Wi-Fi for the time being, right? It's got a a cable like one which Satish showed you yesterday. So let's pretend these two are connected through that cable. So there is a physical medium available for the connection to travel from one to another. Now, when it comes to the sender A opens a notepad, probably a notepad, and then he goes and then types into his browser. Can you see my screen now? I am typing. Can you see this?
No, sir.
You can't see that. I don't know why. Anyway, how do I make this visible? You can't see this. No, that's okay. That's okay. So all I am typing is HTTP. I'm opening a browser, and that browser acts as the application layer. Okay. Okay. Now you on your computer, you open your browser and say HTTP something www google.com. Okay. Now assuming your server is assuming you've got a web server here. Okay, this is B and this is A. On A, you type on the browser HTTP. This might not work always. I'm just giving an example. Don't worry about it. www.b.com. B is this particular guy. Okay, b.com. So, and the data travels. And then followed by some argument, question mark, post, send. This is not an exact command. I'm just giving send hello. So I'm sending the data hello. So this particular thing, which actually is written on the browser, right? Now that browser starts as your first point of contact, which is your application layer. So remember we discussed about 7 layers. What are the 7 layers, guys? What are the 7 layers? Okay, let's write it down here. Okay. 1, 2, 3, 4.
Presentation.
Now let's go through the order. I gave you a code to sort of remember that. So the first layer obviously is the physical layer, or it is called as the layer 1. Please do not, so data link layer, do not, network layer, correct. Then comes the transport layer, throw. So what was the code? Do you remember the code?
Please
Do
do
you
not
remember?
spaghetti and hot dog.
Yeah, whatever. Please do not throw. Please do not. Uh, please do not throw pizza, sausage away. Okay, so let's take the please. Sorry, I you know what I did? I accidentally. Okay, all right. Please do not throw pizza. That's presentation layer. Sausage, session layer. And then comes the application layer. All right. Okay. Now we are sending the data from source A. So the first layer from a sender perspective is the application layer. This one. Okay. This one is the first layer that it has to go through. Where does that happen? You got a browser and the browser is installed on the operating system. The operating system has the command to go to b.com, which for the time being pretend that this is the machine which it is connected to is the B. So it knows where to go to. So what happens is the data hello is getting posted. Okay, you're posting the data hello. So you get a basically a packet. A packet will have the data hello. Okay, now this data has to go from machine A to machine B. This is the objective. The first layer which it encounters is the application layer because it is written from the browser. All right. Okay. Now, as soon as it is written, then comes the session layer. What information will it add? Remember the example which I gave, a post office where someone posted and there is a stamp written. Likewise, this hello will have a stamp written with the session layer. Session layer will say, okay, at this time of the day and sequence of 1, this data is getting sent to source B. Okay. So what will happen? So that session information is getting added to source B. Then comes the presentation layer. The presentation layer should say, what is the protocol which is being used? It says HTTP. It will say this is not a encrypted data. This will be a plain data. There is no encryption applied. Then comes the transport layer. Transport layer will say, okay, so sorry, that HTTP was here. So the transport layer will say it is an HTTP data. The networks layer will add the information that it has to go to b.com. The data link layer will add something called as the MAC address of this guy. I'll show you where that comes from. Okay, now, so the whole information gets added into a big packet of information, and that packet will travel through the physical layer of this computer. It goes all the way here and reaches which layer first? And when it reaches B, which layer will it encounter first? So from the source A, sender A, a packet is going from the application layer through to session, presentation, transport, network, data, physical, and it goes all the way to which B. Once it reaches B, what is the first layer in the network that it encounters? Any idea?
Physical.
Correct. So it reaches the physical layer because it goes to the physical neck card because it goes this way up. Because on the first machine it went this way down, and in the second one it goes this way up. And then when it goes to the app layer, it gets on the browser and then show the message hello. That's what happens. Okay. Now, okay, this is something which we discussed yesterday, so I'm not going to sort of go through that anymore unless you guys want me to. Okay, so now here is my first PC. Let me draw it much more clearly. Session B, sorry. So that's source computer A, and this is destination computer, sorry, B. We discussed how the data is traveling. So the first layer which comes is what? Application layer. Oh, sorry. First layer is app layer. Second layer is what?
Data link layer.
Is it data link layer? The session layer. Then comes the presentation layer. Then comes the, yep.
Yes, sir.
Transport layer. And then comes what?
Physical layer.
No. Do you remember the code? Anyone remembers the code that I gave you?
Please do not throw.
Please do not throw pizza and sausages
Away.
away.
Please
So it's a pizza sausage away. So what's the next one?
network layer.
Then comes what?
Data link.
Okay, so the reason why you're getting confused because I'm asking you for the code which is layer 1, layer 2, layer 3, but I am writing it the other way around. That is why I think you guys are confused. But that's okay. All right. So all I wanted to know, or all I wanted to tell you is, so okay. Now coming to destination B, right? Now, okay. Let me do this. Now, have you seen this? So you saw the physical modem. You've seen the modem and all these things, right? Now, let me ask you guys a question. Okay. Now, in the case of a computer, where do I do this now? Come on. Okay. So now consider this computer connected to a modem. A modem. A modem has got a physical port. All right. Now, that physical port comes as the what layer of the computer? Of the OSI layer? Physical port is always a physical layer of the OSI layer, right? Now, once it comes to it, so it says, assuming one of you has got 5 computers at home, or one computer, a iPad, then another mobile tablet, and all of these. All of these are connected to your Wi-Fi. Okay, so how does a Wi-Fi work? If you look at it, okay, let me open my Wi-Fi. Let me open the Internet Explorer. Okay, new share screen. Okay, are you able to see my screen?
Yes, sir.
Okay, so I issue a command called ipconfig. Okay, I showed you this the other day, right? And I get this one, 192.168.1.114. Do you see that?
Yeah.
Okay, now I have a router at home, and the router's IP address is http 192.168 192.168 1.1. Okay. All right. How did I find that the IP address is 192.168.1.1? That is what is written against the default gateway. I'll tell you what a default gateway means in a short while. But if you see the IP address here, I'm saying HTTP 192.168.1.1, which is actually my router's address. Now, I don't know if I remember my. Okay. Do you see that? Do you see my screen?
Yes, sir.
Okay. All right. Now, okay, what we are going to discuss is a bit technical, but I will try to make it a bit interesting. Now, I am going to go through each of these parameters which is written in this, just to give you a bit of an idea. Okay. Coming back to my, so do you see the screen? Do you see this particular thing, PPOE, PPTM and all that? And then you see, do you see this MAC address 7C, 8B and all that? Do you see that?
Yes, sir.
Okay, all right. So just next step, I'm going to discuss about MAC address. I've got to stop the share to shift to my whiteboard. I'll come back to this in a bit. Okay, so just look at this. You've got this figure. Okay, stop share, new share, go back to whiteboard, share. Okay, now when you, what happens, all right? So we have the 7 layers. Okay, so let's take the 7 layers. App 2, 3, 4, 5, 6. Okay, let's start from physical layer. Physical. Then comes what?
Data link layer.
Yeah.
Network layer.
Yep. Next one.
Transport layer.
Transport layer.
Good one. Good. Transport. Okay. Next one.
Session layer.
Presentation layer.
Correct. Presentation layer. Remember, please do not throw pizza sausage away. Never.
Session layer.
Session layer.
Okay. All right. Okay. Session layer. All right. Now, what happens when a data goes from, so say computer A and computer B, right? So if you connect these two, what happens in the packet is, in the packet you get something called as so in the network operating system, or in the operating system, you get something called as a MAC address. A MAC address is a universal address, which is a unique address assigned to every single computer or a network attached device in this world. Okay, how do I find my MAC address? I go to this, I click IP config. Can I see my MAC address here? Let's see. Let's see if I can see my MAC address here. There has to be a MAC address. No? Why? Oh, sorry. IP config slash. Okay. Do you see this written as physical address? Do you see that? Do you see my screen?
No, sir, we can only see the whiteboard.
Oh, yeah. Sorry. I'm sorry. I just have to shuffle between this whiteboard and the screen just for a sec so that I can show it to you. Okay, so what I did was, okay, so I'll do it again. You can now see my screen, right? I go to my
Yes.
command. You guys can come type this if you want. ipconfig space /all. You might have done this before. Anyway, so when I do that, I've got multiple network cards in me on my computer. So my computer has got a host name, primary DNS, and then all those blah, blah, blah. And then comes my address. So that physical address that you see here is the address of the network adapter that I have connected into my computer. Okay. That is the MAC address. That's called the MAC address. Okay. What is a MAC address? MAC address is nothing but a media access control address. What it is, it's a unique address, which is like a name given to any person. So every network device connected connected to the networks will have a MAC address attached to it. Okay. Now that MAC address, what happens? I'm stopping this share. Now I'm shifting to my other one. It's a bit disturbing. I don't know how to do both together. If it was a whiteboard, I could have done that. Why am I not able to do this? Okay. Share screen, whiteboard, back again, share. Okay. So so when I said that's my computer session, computer A, I took the MAC address. So what happens is when I am sending a data hello, okay, from the application layer, at the when it comes to the data link layer of my network, what happens is the MAC address of my computer, which starts with BA in my case, BA colon whatever that AB, whatever that IP address is, that address get added to the packet. Okay. Now, as I showed it to you, where is my switch? Okay, so this is my switch. I've got a switch here, right? Each of those port, pretend that, you know, this is a switch and I've got 4 computers connected to this using my cable. Okay. Each of those port is called as a network port. Okay. Now, each of those port, whichever device that is connected to that port will have what does it have? It's called a MAC address, right? Each computer which is getting connected to this particular port has got a MAC address, and that MAC address is recorded on this device. Now pretend a scenario where I've got 2 computers connected like this with a device which is a switch here, and it's got 2 ports. A is connected to this port and B is connected to this port. In both the cases of A and B, they have their own unique MAC address, right? Now that MAC address will get recorded onto this device, and that device is called switch. Okay. Now, where does the data come from? The data comes from the data link layer. So when a packet goes from A to B through the switch, when the packet reaches here, this device is able to read only this section of the packet. Okay. It reads this section of the packet and then it records that information. Hey, I saw a packet coming from A, which has got the MAC address, whatever, BA, whatever. Now, when this guy connects to this device, this guy will, this port will read the MAC address of this device and record it here. This has got a BC, CD, whatever. So that MAC address. Now, assuming a scenario where this hello goes from A to B, hello has got a device which has got the message, and then it connects here, it will immediately transfer it to B. Okay, and that transfer happens based on this data. Okay, that is called as a layer 2 switching. Layer 2 switching. Why it is called layer 2 switching? Because it reads the information of the network packet, which is the layer 2 information of the network packet. The layer 2 information of the network packet is the information which is recorded on the data link layer of the network packet. So when someone connects to this device has got the intelligence to read the layer 2 information of the destination packet or the packet which is it is destined to, and it will say, okay, I am going to send this packet to this particular other port. And how will that send the packet? It will read the packet information on data link layer and switches the packet from one switch port to another switch port. Okay, that is how the communication happens. Now, pretend, is this clear to you or is this so confusing? Guys, let me see myself.
So can you hear me?
Yeah, I can hear you now.
Yes. So my mic got synced. So,
Yeah, that's okay, Ritesh. Please talk.
sir, I have a doubt in the application layer. Do we need an application installed to receive the packet or the message?
Of course. So assuming you have sent a packet which was written in Microsoft Word. Okay. Okay. So you send a mail. Okay. If you sent a mail which is written in Microsoft Word, which has got contents which are written in Microsoft Word. So the application layer not encapsulate. That's the wrong word. The embeds the data or slices the data which is sent in a Microsoft. You're sending an attachment or you're sending a file from one computer to another computer. You attach it to you attach that Microsoft Word application, which is an application layer program, and then you send it to the other machine. Now, obviously, when the recipient receives it, because the data was written in Microsoft Word, the recipient should also have Microsoft Word. Technically, now the days have gone where you actually have to use the same application on the other side, because nowadays we have softwares which are written in open source protocols, which means when I say open source protocols, say for example, Microsoft Word condenses the data in a particular format, and that format, if the recipient application can read that format, obviously you don't need a Microsoft Word. So there are cases where you send a Microsoft Word document and you can read it using an open office software which is on the other side. I mean, that's a different, but what I'm trying to say is when you send a document from one computer to another, you should have a writing tool, and there is a reading tool as well. Maybe it is the same tool, maybe it is a different tool, but you need to have a tool to write it, compose it, and a tool to view it. Make sense?
Yes, sir.
So all those happens at the application layer. So the network doesn't care what data is being sent. All it sends is I got a packet, I will add more information on top of it so that it can reach the right location, destination.
Yes. Okay.
Okay. All right.
Yes, sir.
So I was talking about a switch which actually works at the data link layer. Now there are devices which work on the physical layer. Can you think about a device? I don't know if you have seen a device like that. Have you seen a device like that? Do I have that? Let me check. I'm just checking if I have that. No, I don't think I have it. Sorry guys, I don't have it. Okay, I've got some device in mind. I'm not sure if you guys know, there is something called as a hub. Have you seen it? Not sure if you guys have seen it. Satish might have seen it.
Yeah, yes.
Have you seen something called as a hub, guys? Any one of you? Let me see if I can take a picture of a hub. Hub, network hub. Are you able to see my screen? No, right?
No, sir.
Okay. Let me see if I can paste a picture here. Oh, no. It's a bummer. Okay. Stop share. Share again. There has to be a way to share multiple tools. Have you seen this device? Have you seen this device?
Yes, sir.
So,
That device is called a hub. You know why it is called a hub? Because it's not an intelligent device. Okay, it is not an intelligent device. You know why? What is intelligence? I'll tell you what is intelligence, what I mean by intelligence. Okay, so stop share. What I mean by an intelligent device is nothing but, okay, so as I said, so if you have two computers, right, and I've got a physical port here and I've got a physical port here, and there is two cable connected. We don't say that cable is an intelligent device because cable will send whatever comes to it. Okay, we don't say that a network port is an intelligent device because we will send whatever it comes into the port, it will send. Likewise, whatever is received by this port will go into this computer. Okay, and hence these devices, which are a part of the network, which actually conveys whatever traffic which comes to it, in network terminology, is a dumb device. Okay, there is no intelligence attached to it. But assuming, I'm just taking an eraser, assuming I'm just drawing that, I draw a cable, and then I connect to a device here, right? And then I draw another cable to this one, right? Now, if this is connected to a port which reads the MAC address of this guy, and it connects here, if it reads the MAC address of B, pretend a scenario where now this device, which is called as a switch, can actually go and read the packet information which is coming from this device and can recognize where it is coming from because it's got the ability to read the packet, and hence this is called as an intelligent device because it can do some work. It doesn't just pass on information what comes to you. It can read the information and take decisions. Okay, now consider a scenario, a data packet come from A to B, and then it says that in the data link layer, it can say, okay, I'm going from A, I'm destination B. What information does it view in the data link layer? There is some address which I showed you earlier. What is that called? I showed you something which starts with A, B, colon, and all these things. What is that called?
MAC address.
MAC address. So the switch can read the MAC address of A and switch can read the MAC address of B. Now, if the packet says that I'm going to B, what it will do, the switch will actually take that packet straight into B, assuming that there are multiple other ports on this, right? And there is C connected to here, and there is D connected to this device. none of C or D will have any view or visibility of the packet which is coming from A to B, because switch knows A and B are the only guys which needs to be there in that transaction. C and D need not be there. In the case of a hub, you know what happens? The device that I showed you on the computer, it's got multiple ports. You know what happens when, assuming that A is connected to here and B is connected to here, right? This device does not have the ability to view what is there in the packet which comes in. You know what happens when that two devices get connected and data comes here, assuming C is connected here and D is connected here. This guy, what it will do, it will just send that information to B, C, D, everyone. Okay, that kind of communication is called as a broadcast communication. Broadcast communication. What is the problem with a broadcast communication? Can you just think of?
So there's no privacy.
Exactly. There is no privacy. There is, before coming into privacy, there is another problem. Can you think of what is the other problem? Not from a security perspective. Just think. What could be the problem? A is sending packets to B. Okay, it's keeping on sending packets to B. C and D are there. They are not a part of this transaction. What will happen is, when the packet comes into A, it'll send to C, it'll send to D, it'll send to B, everyone. So there will be quite a lot of traffic happening within the device for no reason, right? Because C's network port might get filled up with a lot of unwanted information, correct?
Yes, sir.
And you know what will happen with that scenario? That scenario is called by a name. What is it?
Collision.
Collision. You know what collision? What is collision? Collision is bumping into each other, and bumping into each other might result in what? Loss of data. Because A is sending a lot of information to B, and unwantedly C and D are coming in, and assuming at the same time C and D are chatting, which is supposed to be chatting to each other. So A's information is coming into the device, B's information is coming into the device, information from C and information from D as well. So it's quite a significant amount of information which is just floating around in the device. The device becomes busy. There will be a lot of chatting happening. Hey, are you B? Are you B? Where is B? Because I don't know where B is. That's exactly what is called as a broadcast message. And because of the broadcast message, what happens? There is quite a lot of collision which happens. Collision results in performance issue. So if A was supposed to be reaching B in 1 second, it won't reach in 1 second because it's keeping on searching where B is. And in the process, it might get collided with other ports, other packets. There will be definitely performance issues. Okay. To avoid that, they started getting rid of a hub kind of scenario or hub kind of devices in the network. And then came the more intelligent device, which is called as switch. And the switch, it is intelligent because what does it do? What does it do, guys? How is that intelligent over a hub?
It reduces traffic and it is more private.
Yeah, so how does it reduce traffic?
By only sending information to the device which is required.
Correct. And how does it do that? How does it know it is going to be?
It identifies the MAC address.
Perfect. That's the right answer. So it reads the MAC address it passes the information to the switch to the right port, which has got its destination MAC address as well. So a packet which comes has, we discussed about different layers, different layers add different information. Layer 1 is the physical layer. It doesn't add any information. It is a dump layer. It doesn't add any information. Sorry, not layer 0, layer 1. Layer 2 adds the MAC address. MAC, MAC address. Next comes the great, what layer? After physical data link, then comes what?
Network.
Yeah, then comes the network layer. What does network layer add information into? The network layer adds information which is called as the IP address. Do you know what is IP address?
Yes.
What is IP address?
So
What is IP address? Sorry? Your voice is breaking, man.
So the full form of ID or
No. Okay, full form is nothing but Internet Protocol address. What is IP address? Okay, so I have to excuse my, you guys have to excuse me today. I will have to do a stop now. I've got some unplanned activities which has come up. What I would ask you to do for the next class before is try to find out what IP address is. I will definitely explain to you. Don't worry about it. Try to understand what IP address is, and then let's have a discussion around that in the next class. However, what we discussed today, out of the 7 layers, we discussed about the physical layer and the data link layer. We sort of discussed what are the 2 different devices which work on these 2 layers. On a physical layer is what? The network interface card or a hub. It's acting as a device which performs or which works on that layer of the network. What is the next one? The data link layer. What is the device which works on a layer 2 or data link layer? What is that device called? What is that device called?
Hub.
No, hub is on the physical layer.
it's a switch.
It's a switch. So it is called a switch because it can quickly switch the packet from one port to other by reading the data link information or layer 2 information. Okay, the next one we are going to discuss about is the layer 3. Before we hit into layer 3, we will have to go through the IP address. Otherwise, you won't understand what layer 3 is all about. Okay, then when it comes to layer 4, we need to understand some protocols, what is encryption, what is decryption, and all that. So there will be 2 more lessons, 2 more classes, which I will be discussing these devices in detail, why that is called such, and I will also be discussing what are the functions of those devices, what are the used cases of those devices. Where is a switch used today? We all use switch in one shape or other. And where is it used? It's used in every home as a device which is used to connect multiple devices within the house, right? Now there is something called as a router, which I will be discussing in the next class. And before hitting into the router, I will have to discuss what is IP address. Okay, and that's a bit elaborate. And for me to explain IP address to you, it might take another 30 minutes, which extremely sorry, I don't have time today, but I'll definitely go through that in the next class. And that will give you a bit of view about what was I showing on that command prompt where IP config and all that. Now you will be able to relate to what I was doing and where is it working and stuff like that. Okay.
Sir, I have a doubt.
Yep, please, Ritesh.
Sir, do telecommunications use hub or switch?
Good question. So hubs are not used nowadays because obviously hubs are not very performance intensive, right? Hubs are used only in, if I've got 2-3 computers to be connected on this table, I can use hub because I don't mind about performance and all these things. But switches and routers and some other devices are going to be are the devices which are used in the telecommunication industry.